Good morning, colleagues. I would like to welcome you to today's webinar on performance-based standards for heavy vehicle design and operations. We are pleased to have you with us as we explore how PBS is transforming heavy vehicle safety, productivity, and efficiency in South Africa. So today's session will take us through the PBS design approach, lessons learned from the local smart truck pilot, and the steps involved in the PBS application process. So we are honored today to have Dr. Paul Nordengen with us. He is a leading expert in the heavy vehicle transport technology. So please feel free to post your questions when we are in the presentation. Please use the chat to post your questions, and Dr. Paul will respond to them after each presentation. So once again, thank you for taking the time to join us. We are looking forward to an informative and engaging session. Over to you, Dr. Paul. Thank you very much.
Hi, Amon, and good morning, everyone. I'm just busy sharing my screen. It's a pleasure to be presenting at this webinar. Yeah, I've been involved in the project since it started, and I'm very passionate about this performance-based standards approach for heavy vehicle design, especially in terms of heavy vehicle safety. But I think I know that there probably a number of you who joined us today who are quite familiar with the PBS approach. And so my apologies, if you already know quite a bit. Some of you may have attended the RTMS PBS awareness workshops that we normally hold. I'm one of the RTMS non-profit company directors, and we hold these workshops 4 or 5 times a year. And I normally give a very condensed presentation in about 20 minutes of the whole PBS approach and the pilot project, etc. So this is an expanded webinar. We have divided the webinar into 3 presentations. The first one is the design approach, which is really important. So what is PBS? And then the second presentation is on the pilot project in South Africa, which has been actually, the committee was established in 2004, and the first 2 PBS vehicles started operating in the forestry industry at the end of 2007. So it's been going for quite a long time, and there are various reasons why this pilot project has been extended for such a long time. And then lastly is just, as Amon said, the application process. How do I get involved? And that's a relatively short presentation. I think one thing just to clarify again also is that PBS, or the performance-based standards approach, it's an approach that can be applied to any vehicle. It can be applied to a rigid truck that complies with the regulations. It can be applied to a B-double or interlink, a 22-meter, 56-ton rig. It can be applied to that. The PBS approach in this pilot project that we've been running allows for what we call high-capacity transport or high-capacity vehicles. So most people associate the PBS approach with these high-capacity vehicles, but it's not the same. The condition for allowing these high-capacity vehicles is that they must comply with the performance standards, which ensures less road wear per ton of payload, much more stable vehicles, less likely to roll over, etc. And that is, and the same applies in other countries. So they use the performance-based standards approach as a tool to give exemption to vehicles to be longer and heavier, and operates on limited or approved routes. But we still talk about PBS vehicles. I talk about PBS vehicles. In Australia, they talk about PBS vehicles, but actually we're talking about high-capacity vehicles. So I think most of you are familiar, or hopefully familiar with the Road Transport Management System, or RTMS. It's quite well established in South Africa now, and it addresses sort of basic operational requirements. And I know in the dangerous goods environment, it's a much more controlled and regulated environment. So a lot of dangerous goods operators are already, doing everything that and more that are required by the RTMS accreditation scheme. But the RTMS addresses things that the words that are highlighted in red. So road infrastructure, in other words, minimize overloading, ensure vehicle maintenance, also operation, that should be highlighted in red. So things like speeding and then also particularly driver skill to ongoing training, driver wellness, and managing fatigue. The PBS approach focuses on the vehicle design. So that's what we're going to be talking about today. So going back, this pilot project was started and way back in 2004, South Africa was the 4th country in the world to implement a performance-based standards approach for heavy vehicles. So PBS has been around for quite a number of years in other sectors like the medical sector, agriculture, road construction. It's not something new. And if you Google it, you'll see that there are a lot of different sectors that are applying a performance-based approach as opposed to what we call a prescriptive approach. So South Africa was the 4th country, and we decided, we got approval from the Minister of Transport at the time to run a pilot project, and we would monitor certain things, comparing these PBS vehicles with standard trucks and look at reduced road wear per ton of payload, reduced number of trips, improved safety performance, look at the crash rates, transport productivity, fuel consumption, reduction in emissions. And then also, one of the obvious things is if you've got less trucks to move the same amount of freight, then your queues would be less. So at things like the mines, power stations, cross-border, border posts, at the ports, less trucks means shorter queues. So this was just an overview of the National Overload Control Strategy that was done when I was at the CSIR for the National Department of Transport. And in that strategy, we recommended looking at self-regulation as a way of complementing law enforcement, which then became the RTMS, and also to look at the performance-based standards approach. So that's where it all started quite a long time ago. We decided right at the beginning that the RTMS certification would be a requirement to ensure a minimum level of professionalism of an operator who wants to operate these high-capacity vehicles. So without going into detail, the RTMS is self-regulation. It's based on an SABS standard, SANS 1395, and you get audited once a year to ensure that you're not overloading, you're maintaining your vehicles, you're training your drivers on a regular basis, managing their health, etc. So that was a requirement. So hopefully none of you are running vehicles in your fleets that look like this. But the fact is that in South Africa, and generally speaking in developing countries, you have vehicles on the roads, buses that are not roadworthy. In fact, some are very far from being roadworthy. And we cannot afford, and that is the reason for the RTMS requirement, to have very unroadworthy vehicles, drivers that are not properly trained, that are driving too many hours a week, etc., running high-capacity vehicles. And many of you will know about the Brake and Tire Watch. It's a Fleet Watch initiative. And they've had over 50 events now. I've kind of lost track. But consistently with these 2-day training events, where on the second day they inspect trucks that are randomly pulled off the road, they've been held all over the country and in Namibia, the figure still is about 69% of the vehicles that are inspected are not roadworthy. They are discontinued from use. So that is a scary thing, and brake linings are often, on the trailers especially, are not maintained, they don't exist. I even had a phone call earlier this week or last week from a guy on a runs a truck stop on the N4 near Rustenburg, complaining about how bad some of the brakes are on these trucks. And tires. Tires obviously extremely important from a road safety point of view, but also from a fuel consumption point of view. You know, if your tires are not properly maintained and you maintain the correct pressures, it's not only unsafe, but also it increases your fuel consumption, and it can increase the road damage. So the idea of our regulations in South Africa has got a very good set of road traffic regulations. We call them prescriptive regulations, is to ensure that vehicles on the road are safe for other road users and they don't cause undue damage to the road infrastructure or any, the reality is that many trucks are not safe, especially from a dynamic stability point of view, despite the fact that they comply with the road traffic regulations. And this came out, which is really the background or the beginning of the performance-based standards approach at the University of Michigan in the 70s and 80s, did a whole lot of research for the Federal Highway Administration looking into the reasons for so many truck rollovers in the United States. It was about that time about 10,000 truck rollovers per year, and the Federal Highway Administration wanted to find out, you know, what are the causes for this. So they did a whole lot of research on vehicle dynamics. So here I just got a few little video clips showing, this is from the US. This is typically what happens because a truck's center of gravity height is so much higher than a car, for example. The probability or the risk of it rolling over is much higher. So you've got to manage your speed, but there's certain things on a truck which are not prescribed by the regulations, which can greatly improve the stability of a truck. So here's a rather scary video of a truck going not that fast. If you look at the bottom, you can see it's 27, 28, 29 miles per hour, which is not very fast, and yet going around this curve, it actually rolls over. So how do we address this? This is from in Pinetown a few years ago. Obviously, the truck is going too fast, but nevertheless, this is the kind of thing that we're trying to address and reduce truck rollovers. This is in Cape Town on the N1. If you look at the vehicles approaching the screen, you'll see a truck coming along, going too fast, and it's a single vehicle crash. It's a rollover. And here, just to illustrate the fact that a lot of these performance standards are not just applicable to longer trucks. This is a fire engine, and it's a rigid truck. It's also probably going too fast, but it's got a lot of water in it, and he ends up on his side. So the performance-based standards approach is a fundamental shift from the prescriptive approach. A prescriptive approach, which is used throughout the world, defines what a vehicle looks like. So it limits masses and dimensions and a few other things. It does constrain productivity and it constrains innovation, because we know, as with most technologies, including truck technology, it moves very fast. But regulations, to update regulations takes quite a bit of time. So there's always a lag. But if you approach it from a performance-based approach, it promotes innovation. It makes trailer manufacturers and OEMs think, and transport operators think laterally and come up with designs that are safe, because they have to pass all the performance standards, but are more productive and safer. So when we started with this project, the Australians had done a huge amount of work, and they'd already introduced PBS's approach in their legislation in 2008. So all the safety standards we took And we said, look, let's use those. They're very similar to the ones in New Zealand and Canada at the time, but they're not all exactly the same. So we decided to use the Australian performance standards. We developed a strategy which was approved by National DOT and a rules document. The latest one is actually 2024, and we're busy with a new version. And those are the rules that you have to comply with in order to participate in the project. So talking about the actual performance-based approach, what you do is you put the vehicle through certain maneuvers, slow speed and high speed maneuvers. And these are not cast in concrete. It came out of a lot of research to say, let's look at a low speed turn, a high speed lane change, a rollover test, etc. Then there's the drivability standards at the bottom, which look at the power and the torque that the truck has in order to pull the load, that payload, at a reasonable speed and be able to accelerate at a reasonable rate. So those are the maneuvers, and then the actual performance standards are on the right-hand side. Now these were defined, developed, and said, for a vehicle to be acceptable from a performance point of view, it must comply with these performance standards. And there are actually 16 altogether if you include 20 altogether if you include the infrastructure standards, which are South African based. So I'll show you a couple of examples. Here's a low speed swept path. So the vehicle goes through a 90-degree turn at 5 kilometers an hour, and then you get off tracking. And that off tracking cannot exceed a certain dimension. I'm not going to go into the different levels, but in fact, the fuel quotes that are running in South Africa are level 1 PBS vehicles. They have general access, so they're not limited to specific routes. Most of the PBS vehicles in South Africa are level 2, and there's a few a bit higher, but the level 2 have to only operate on approved routes. So the level 2 swept path maximum is 8.7 meters. Here's just a little clip showing 5 different trucks doing the same maneuver, and you can see the off tracking. So this is a prescriptive vehicle, truck, tractor, semi-trailer. There's a little bit of off tracking. The second one is also a prescriptive vehicle. It's 19 meters long, and because it's got 2 trailers, you can see that off tracking increases. It starts to encroach on the opposite lane. This is now a 20-meter PBS vehicle. So it's been designed to have a maximum swept path. So even though it's 1 meter longer than the previous vehicle, it performs better. This is a 25-meter prescriptive vehicle in Australia, and it's got a very poor off-tracking performance because of the long wheelbases, especially the second trailer. And you can see how much it cuts into the opposing lane. And then the last one is a 26-meter A-double, and it's a PBS vehicle, and you can see how it does that curve. And the next presentation, I'll show you an example of a Coca-Cola PBS vehicle that's 30 meters long, how well it performs. So that clip should illustrate the difference between a prescriptive approach, which specifies the maximum length of the vehicle, and a performance-based approach, which specifies a maximum swept path. And from a slow speed performance point of view, that's what you're really interested in, is the swept path. How much space does a truck take when it turns into the gate or goes through an intersection? That's a big safety concern. So that's the swept path. That's a performance standard. Not the vehicle length, but the space that it takes up. Then you've got a high-speed lane change maneuver that's also been defined. It's an SAE standard, SAE J2179, and that is quite an aggressive lane change. And what you do is you look at how much the rear trailer sways from side to side when it does that maneuver. So this is the baseline vehicle. The first timber vehicles that were this is a standard truck, 22 meters long, and it's a rigid truck with a drawbar trailer, which is very common in the timber industry. it failed, this high-speed transient off-tracking. As you can see, it doesn't look very stable when it does that high-speed lane change maneuver. The one on the right was the first PBS vehicle in timber. It's also a rigid truck with a drawbar trailer. It's 27 meters long, 67.5-ton combination mass, and it was designed to pass the performance standard, this particular performance standard. So it does exactly the same lane change, but you can see how much more stable it is. And just for interest, one of the big features or very critical features for a rigid truck with a drawbar trailer, which Australians call a truck and dog, don't know why, is the underslung hitch. So you want to move the hitch position as close to the drive axle unit as possible, and that minimizes this instability. A lot of the traditional rigid truck and drawbar trailers, the hitch position was too far back, which introduces this instability. So it's not something that's governed by the prescriptive regulations. There is a maximum drawbar length, obviously, in the regulations, but the position of the hitch can be in various positions. So if you apply the performance-based standards, you will design the truck and the trailer so that it's actually a lot safer. Here's a test that we did at Gerotech, exactly the same thing. So these tests you can do in the field. And this was a side tipper with a bladder in. So to try and model the moving of the fluid in a bladder in a side tipper, that truck was instrumented. The guy was doing his PhD at University of Pretoria. So we did these tests at Gerotech. This is the static rollover threshold, another performance standard, which is probably the most critical standard for all trucks. As I said, whether it's a rigid truck 10 meters long or a combination of a vehicle combination. This was the first SA Breweries PBS vehicle, 30 meters long, an A double, and that's the red one. And the blue one is the baseline vehicle. So with this performance standard, you have a standard horizontal curve radius, and you accelerate the vehicle gradually. This is all done with computer simulation until the truck rolls over, or the trailer. And that lateral acceleration at the point of rollover must be at least 0.35 G. And as a matter of interest, for dangerous goods vehicles and passengers vehicles, it's 0.4 G. So it's even more strict. So you can see here the simulation, or that baseline vehicle rolled over at 0.27 G. So it only required 0.27 G of lateral acceleration to cause the vehicle to roll over, whereas the PBS vehicle was designed such that it only rolled over above 0.35 G. And this is a performance standard that affects all trucks. You can also do this simulated on a tilt table. This was also a Gerotech, where you tilt the table and you relate the angle of tilt with the static rollover threshold. And there are chains that stop the truck from actually rolling over, fortunately. But that angle there, one can relate to the static rollover threshold, or 0.35 G requirement. Tail swing is another slow speed performance standard, which is only applicable to certain types of vehicles, in particular car carriers and buses. For most trucks, the tail swing is not a critical, it's not a critical performance standard, but as the truck does a slow speed turn, the rear corner of the trailer starts to swing out, and that amount that it swings out cannot be, more than 0.35 meters. And I'll show you some examples in the next presentation of how bad the tail swing of the car carriers in South Africa was before we introduced the RTMS requirement. A rearward amplification is another performance standard where you put in a pulse at high speed, a pulse at the steering wheel, and you measure the amount that the trailer sways from side to side. So you can see here also the animation. As you do the pulse, there's the baseline and the PBS vehicle. You can see how much the baseline vehicle sways more than the PBS vehicle. And that's got to do with things like suspension, stabilizer bars, position of the fifth wheel. There's a number of features, a number of axles, whether you've got dual tires or single tires, all those things contribute to the performance of the vehicle with doing these various maneuvers. Now, as I mentioned, the infrastructure performance standards are based on South African pavement design and bridge design. And so I'm not going to go into too much detail, but this graph just shows how the blue diamonds are baseline vehicles. These are all mining vehicles, all side tippers. And the red blocks are the PBS vehicles. And in fact, one of them is a 185-ton road train that is used at Richards Bay Minerals. And we work out the load equivalency factor or road damage per ton of payload. And so you can ensure that the PBS vehicles are so-called road friendly. The main difference between those red blocks and the blue diamonds is single or dual tires. So unfortunately, in South Africa, our regulation, we allow 8 tons on an axle with single tires, and those axles, if they loaded up to 8 tons, cause a lot more road damage because of the higher stresses. The contact area is much smaller than with dual tires, so that's a fact that trucks with single tires are causing a lot more road wear than dual tires. And with the PBS approach, we've set a limit to make sure that the vehicles are road friendly. And with the bridges, we actually go to first principles. We look at a range of bridges, assess those bridges with the PBS vehicle versus a reference load. We calculate maximum bending moments and shear forces on a range of different spans. And there has to be a minimum factor of safety of 15% from the reference load, which is already conservative. So we can, without applying the regulation 241, which is the so-called bridge formula, which is very conservative, we use this more a performance-based approach, which allows a higher intensity of load on the trucks. So as I mentioned at the beginning, the RTMS is an accreditation scheme which ensures professional and compliant operators, well-maintained vehicles, and competent drivers. That's the one pillar. And the other pillar is the performance-based standards approach. So it's looking at high-speed performance, slow speed, which is maneuverability on the route, and looking at the vehicle infrastructure match. So these longer and heavier vehicles are limited to certain routes. And normally the challenge is the last mile and the first mile. If we're talking vehicles that are, say, 24 meters and longer, so once they're on the highway, it's generally not a problem, but it's the first mile and the last mile to make sure that they can safely access the loading point and the offloading point. And then the benefits are reduced fuel consumption per ton kilometer, reduced emissions, fewer trucks on the roads, besides the fact that they are safer. So what we're trying to do actually is to optimize what's called here as a heavy vehicle performance envelope without going beyond acceptable boundaries. We want to get the most out of our road infrastructure to get the most productive and safe vehicles on the road, because unfortunately, the reality is that the number of trucks are increasing year by year. The rail situation is not helping, and we can't just keep building new roads. It's just beyond, and that's a reality in most countries. There's a limitation in just building new roads. So somehow we've got to address this challenge. Since we started the project, there's been a lot of work done around the world. The OECD, which is a mainly a Eurocentric organization, has done a lot of work. They have a section called the International Transport Forum, and I've been involved in some of these projects, and most of them are looking at the performance-based standards approach for addressing some of the challenges with heavy vehicle freight transport. So these are the potential gains which I mentioned, and we've been monitoring them. Just as a matter of interest, I've been involved in this forum for many years. It used to be called the International Forum for Road Transport Technology. And it's now, that's the website. The website address has stayed the same, but it's now called the HVTT Forum. And this forum of people from a number of countries around the world share information about heavy vehicles, heavy vehicle safety, etc. And every 2 years they have a conference, HVTT conference, and you can see them all there. We even had one in Johannesburg in 2004. And that's a really good conference to attend if you're interested in things related to heavy vehicle safety and performance and etc. The last one was last year in Quebec City. I've been fortunate to attend all of them since '95, except the one in 2023. The next one is in Slovenia, and it's a joint conference with the International Society for Way in Motion. We've had a couple of joint conferences in the past, and this one will be in Ljubljana in May 2027. So thank you. That's the first presentation. I'm not sure if there are any. I haven't been watching the chat, but there might be some questions.
Thank you, Dr. Paul. There is one question, I think, from Willem. He's asking, what is the total allowed length for a PBS? And what is the total kgs that a PBS is allowed?
Okay, well, it's a good question. So for the maximum length that we're allowing in the pilot project is 30 meters. The maximum mass is really governed by the one regulation that we haven't put aside, is that 5 times the mass on the drive axle unit. So the maximum mass on a drive axle unit for tandem is 18 tons. You multiply that by 5, you get 90 tons. So so for the level 1 and level 2 vehicles, we're talking about a maximum length of 30 meters and a maximum mass of 90 tons, on condition, obviously, that it passes all the performance standards. There are a few exceptions. When we talk about a level 3 and a level 4 PBS vehicle, then they start using a tri-drive. I should have I think there is one in my next presentation. There's a timber vehicle, PBS vehicle, that's got 14 axles. It's actually only 30 meters long, but its maximum mass is 111 tons. And the one that was used at Richards Bay Minerals, 185 tons. So there are exceptions, but those the route approval is quite strict, and that has to be approved by the province.
Thank you very much. There are no further questions.
Okay.
Just a moment. I think there's just one that just came through. Do you know when Mpumalanga and Free State will be issuing concept approvals for new projects? We have just been speaking about that before the webinar started.
Yeah, it's a very good question. I was going to address it later, but I can answer it now. Free State are issuing new concept approvals. So the concept approval is something I'll touch on that in the last presentation. On the 30th of October last year, after quite a lot of engagement with National DOT, the MINMEC committee approved a 3-year extension to the pilot project. The reason that was done through motivation through the National Logistics Crisis Committee, SANRAL had some questions about some further research they wanted to be seen to be done regarding the impact of PBS vehicles on the road, pavement and bridges. So the recommendation was to extend the pilot project for another 3 years, and that was approved on the 30th of October at a MINMEC meeting. So Free State then immediately said, right, they're going to start issuing new concept approvals. Unfortunately, Mpumalanga, in their wisdom, decided they're not. So that is a current problem. And a lot of operators have challenged, especially the N3 goes through Mpumalanga for 44 kilometers. And we are trying to address that through various channels. And in fact, we had a meeting scheduled with the Deputy Minister for yesterday. That has been postponed till tomorrow. So hopefully that meeting will go ahead tomorrow morning at 9 o'clock. And that's to brief the Deputy Minister on the RTMS and PBS projects. And on the agenda is the current status, which will include the concern of Mpumalanga. And various associations have also written letters to the Minister of Transport and also the MEC in Mpumalanga. So as I say, there's a number of efforts to try and to get that, unlock that problem, because you can't carry on with a national pilot project for 3 years with one province, especially in Mpumalanga. It's a key province in terms of routes. Also the route to Maputo, not issuing any new concept approvals. And it's not only for new projects. A lot of the operators, after so many million kilometers or 1 million kilometers, typically replace their truck tractors of their PBS vehicles, and they can't always replace it with exactly the same truck tractor. So if you change a truck tractor, you need an updated assessment, you need a new concept approval. So they also stuck. And I speak to operators on a weekly basis who have that problem.
Okay, thank you very much. There's one more question. Is there a limit to the amount of trailers on PBS vehicles?
No, there isn't. Surprisingly, I've been amazed at, because that's really up to the provinces. When you apply for concept approval, which I'll talk about in the last presentation, you have to have a GA drawing to show what the truck looks like, and you have to indicate what routes you want to operate on, and you have to specify the commodity or commodities that you plan to transport, and also the number that you want to apply for. So, I mean, I know of operators who've applied for 100 and they've got approval. So some operators apply for 5 or 10, 30, 50. I think 100 is the maximum that I'm aware of. But, you know, that's quite a lot.
Okay, thank you very much. We have no further questions for now. I think we can go into the next presentation.
So as I mentioned, the project started in the timber industry, and we've been monitoring, trying to get as much. Sometimes the operators are a bit slow in submitting their data, but we chase it up through the CSIR and get as much data as we can of the PBS vehicles and baseline vehicles. So that you can see this infographic. Timber is still the biggest sector using PBS vehicles. We've subdivided mining into a different number of sectors. So chrome is very big, coal is big, then mining, then heavy mineral concentrate, which is the stuff at Richards Bay. Then you've got petrochemical, manganese, etc. Beer, beverages is Coca-Cola mainly, and a whole lot of others, very small ones. But that's basically the commodities that are being transported. It's the high capacity vehicles are ideally sort of for bulk materials. That's, although you can do other things. Containers is another obvious area, which could be mixed goods, but bulk materials is kind of the best commodity. And as at the end of January, we had about 90 PBS operators, 2,350 PBS vehicles operating in the country, and around about 650 million kilometers that have been monitored. So it's now we've got quite a substantial. Now that's okay. So in some cases with the longer vehicles, when you, as I mentioned, the first mile and the last mile, the province might require a traffic impact assessment to look at the specific route. And this is just one of the consultants uses a drone just to video a particular intersection or curve, and then can simulate the PBS vehicle through that intersection to see that it can safely maneuver. So that is sometimes required, a traffic impact assessment. This is an example that SA Breweries did at a particular intersection near Prospecton, and then also at their brewery, to make sure that this 30-meter vehicle could negotiate safely through those intersections. Route compliance is important. At the moment, the telematics system, you have to keep records of your routes that the PBS vehicles are using so that they can be audited. And this has become a little bit of a problem with some of the operators not complying with the route, their approved routes. We have had feedback from various people, and I think compliance is one of my biggest concerns with this project as it expands. And we've discussed it regularly at our review panel meetings. And we agree that we have to use technology. We have to use technology to ensure compliance as far as possible over and above the RTMS. Because if we're going to get a lot of operators who are wanting to run PBS vehicles for the bigger payload and the bigger profit, but they're not passionate about compliance, it's going to become a mess. And in fact, the risk would be that the whole project could be cancelled. One of the things that we've looked at, which is possible, is obviously a lot of operators that their control centers, they monitor the location of the vehicles. And with that, you can have exception reports that also get sent to the road authority to say that the vehicle has gone off the route, and also speed. You can monitor speed of these vehicles, and if they go above a certain limit, then you get an exception report coming via SMS or email. So those are sort of things that we have to look at to ensure compliance as far as possible. Okay, I'm just going to give you a couple of examples. It started off in the forestry industry. I'm sure you all are aware of the prescriptive regulations, 22 meters, 56 tons for a combination of vehicles. These were some of the first vehicles in forestry. That was the first one that I showed you the simulation. They're required to have abnormal load boards. That was the other one. This was a Mondi project, 24 meters. I think it was a 67-ton maximum combination mass. So you're looking at an increase in payload from 35 tons about to maybe even 40 to 50 tons. Oh, excuse me. Some more example, then the side tipper industry has become very popular for PBS vehicles, and most of those are not over length, 22 meters long. They have additional axles, they're dual tires, as I mentioned earlier. So the roadway, in some cases, the roadway per ton of payload is reduced by 40% because of the fitment of dual tires. But of course, those tires need to be properly inflated. If they're not, then the roadway will increase. Especially, you get cases where the inside tire is neglected in terms of tire pressure. So the outside tire is monitored for tire pressure, and then if the inside tire of the dual tires is not properly inflated, you in fact back to single tires, which is even worse because a dual tire's got smaller tires than a than a super single. So you've got to make sure that the dual tires the tire inflation pressure is managed properly. There's the, now that one is not, that's a 13 axle, but there's a 14 axle as well. Sorry, I'm not going to count now. But anyway, there are two combinations that are running as road trains. That was when the rail operation ended, going from Richards Bay to FSAICE south of Durban. 50% of their timber was being delivered via rail, and that stopped due to some floods, and one of the bridges was washed away, and Transnet decided not to repair the bridge. So suddenly all that timber had to go over to road, and the KZN DOT approved this road train. I actually drove on this last week. It's got a Volvo 700. It was such an education for me to see how that truck, how the driver runs that truck on the hills, going up and going down, using a hydraulic retarder to maximize the speed, or to limit the speed going down hills. That's limited to 111 tons, and the load that we had when I drove was 101 tons. So that's quite a significant load, and you can see it's got a tri-drive. The Volvo 700 is a tri-drive axle. So yeah, that's kind of some of the bigger ones that are running, but these would be limited to very specific routes. Barloworld was running a sugar bottom dumper some years ago, and more recently, grain carriers have started running a similar one in Namibia for grain, and they plan to run it in South Africa as well. It's also not over length, it's 22 meters, but with the extra axles, it has, I think the payload is around 50 tons. I saw Peter was on the thing, but on the group, the webinar today, this is a Goldfields for transporting paper reels. I can't remember. I think this is about 25 meters long, and I can't remember what the maximum payload is. There's another road train running down near PE from the manganese stockpile, it's called Katanga, to the two harbors, Kucha and Port Elizabeth Harbor. So when the ship comes in, they need to load 70,000 tons roughly as quickly as possible. So they have this stockpile. So the manganese is transported from the Northern Cape down, most of it to the stockpile. Some of it goes directly to the port, but these are containers that the cranes can pick up, and then they drop the one side and the manganese falls into the ship. So this is also a road train that was specially approved for those two routes from the stockpile to the ports. And it greatly reduces the number of trips. You can imagine the roadway is less, it's a safer vehicle, it's a big benefit. The fuel quads have been running for quite a number of years. Unitrans was the first company, and then Manline. Reef tankers are running them as well. I'm not sure. Southern Star in Swaziland or Eswatini. So that's a 55,000 litre tank. And then the quad axle at the back. At the quad axle unit is allowed up to 32 tons, so 8 tons per axle. It's got a steer axle right at the back, and the front axle of the quad is a lift axle. So when it's unloaded, they lift that axle. This is a 6-meter containers, and that's the quad, the fuel, the BAB quad that I was talking about. They're not running this anymore. The 4 trailers, they've gone down to 3 trailers. But so this shows you the original combination at the top, which you call it's actually an A triple. And that wasn't a PBS vehicle. They got an abnormal load permit to run this 3-trailer combination, and they wanted to increase to 4 trailers. So the KZN DOT and the Western Cape, where they were running this, the Western Cape, it's Namakwa Sands, they said, yes, we'll allow you to go up to a 4-trailer combination, but it must comply with the performance standards. So with all the PBS projects, we analyze the baseline vehicle, which is the current vehicle, And so here you can see on the left is the baseline and on the right is the PBS vehicle. And that A triple was very unstable, mainly because of the quite long drawbars, 2 drawbars and fairly long, whereas the PBS vehicle has only got a single drawbar. I'll go back to the, you can see the baseline had 2 fairly long drawbars. That was to try and spread out the load. And the PBS VAB quad, we call it, has just got 1 drawbar. The drawbar improves maneuverability, but it reduces the high-speed dynamic performance. So you've got a tension between the low-speed performance standards and the high-speed performance standards. So usually when you make a change on the combination, the slow-speed performance will either improve or get worse, and the high-speed performance standards will do the opposite. So you've got to sort of find this so-called sweet spot to pass all the performance standards. Here you can see the triple. So this is not the same as the baseline triple. This is a new triple. It's a PBS triple. It's got fifth wheel couplings rather than drawbar couplings. I think this is limited to a maximum combination mass of 135 tons. Some examples of various PBS vehicles, even the Buscore PBS buses in Mbombela, 27 meters long. And you can see their crash rates. If you look at their solo buses, this is now from 2014 to 2022, their solo bus crash rate was 9.5 per million, and their biarticulated buses, which are the PBS buses, it's 5 crashes per million kilometers. And in fact, they designed a biarticulated bus, which they were trying to get approved, to get permits to operate it on various routes in Mpumalanga. This is quite a number of years ago. And that top design was what they wanted to run. So that was what they had originally designed. And then we managed to convince them to do a PBS assessment on the bus to see if it passed all the performance standards. And remember, I told you earlier that the passenger vehicles and dangerous goods vehicles, the static rollover threshold requirement is 0.4 G, not 0.35 G. And the bus actually failed 3 of the performance standards, one of which was tail swing, because it's got that bus has got a large rear overhang. So when it goes around a corner, that tail swings out quite a lot, which is a safety concern. And it failed the rearward amplification as well, and one other. And the WITS did the PBS assessment, my colleague Frank at WITS, and the only changes that they had to do to pass all the performance standards was to increase the 2 wheelbases. So you can see they changed the middle trailer, if you like, with the middle compartment from 4.45 to 4.9 meters, and the back part of the bus from 4.75 to 5.4 meters. They increased the wheelbases, which greatly increased the stability of the bus and also reduced the tail swing because the rear overhang was reduced considerably. So sometimes you can have a combination that looks okay, but it fails some of the performance standards, and with some fairly minor changes, you get the much improved performance. ZZ2, one in Beefmaster were running a triple for a few years from Christiana to their abattoir in Kimberley, but for various reasons they stopped that. This was the first PBS vehicle in Namibia for salt, also an A double, 30 meters. And the photographs there show the launch that they had with the mayor of Walvis Bay cutting the ribbon. And so this is a very short haul from the salt mine to the port. It's 18 kilometers. And they were running standard trucks. With this PBS vehicle, they're saving 532 trips per month. So the kilometers saved is not that great because the lead distance is quite short. but there's a great reduction in the number of trips. And then this is the second one, which is two 40-foot containers for frozen fish, also in Namibia. There, the number of trips is not that great per month, but the lead distance from Luderitz to Walvis Bay is significant. So they are saving about 33,000 kilometers per month because of this PBS vehicle. And to my knowledge, they've had no crashes. They've been running for about 4 years now, I think. I'll skip that one, but no, maybe I won't. This was the SA breweries in the Eastern Cape when they started their project with, I can't remember how many vehicles, maybe 5. And after 3.5 months, they measured a 28% savings in kilometers and a 12% savings in fuel. We did a bit of an analysis on overtaking. So the first thing that a lot of people say is 30-meter rig, it's, overtaking is a big problem, and blah, blah, blah. So one of my colleagues did a little bit of analysis. I'm not going to go through all of these, but if you look at the top one, that's a standard 22-meter rig, traveling at 80 kilometers an hour, and you take a car, not a fancy BMW, but just a standard motor vehicle, accelerates to 120 kilometers an hour, and the overtaking time is 9.2 seconds. Now, if you go to the bottom one, it's a 30-meter rig, also traveling at 80 kilometers an hour, and you do the same overtaking maneuver, and the overtaking time increases to almost 10 seconds. So there's a 0.8 second increase in overtaking time. Now, one might ask, well, why is it so little? And the main reason is that most of the overtaking time is the acceleration from 80 to 120 kilometers an hour. So if you increase the length of the vehicle that you're overtaking by 8 meters, that extra 8 meters, the overtaking vehicle is already doing 120 kilometers an hour. So the increase in overtaking time is fairly small. But if you look at the middle one, which is a truck doing 110 kilometers an hour, the same overtaking maneuver, it becomes over 18 seconds. So it's the difference in speeds of the two vehicles that makes a very big difference in the overtaking time. And you'll see from the crash rates at the end of this presentation how good the PBS vehicles are performing. In my view, the problem of overtaking is when the vehicle overtakes where there's a solid line. And that's where a lot of the crashes occur, not because of the length of the vehicle. It's non-compliance of the overtaking vehicle, overtaking on a blind rise, etc., that causes most of the problems. And in fact, also with SA breweries, we said for 200 pallets, you need 7 trucks, 7 trips. With a baseline vehicle. With a PBS vehicle, you only need 5 trips to carry the 200 pallets. So if you take into account the overtaking time of those 2 vehicles for those 200 pallets, the baseline vehicle actually has a 31% increase in total overtaking time. So to overtake those 7 vehicles compared to overtaking the 5 PBS vehicles is a 30% increase. And then, of course, if you're overspeeding, those percentages go very high. So one's got to look at overtaking carefully before you start jumping to conclusions. The car carrier industry has their own roadmap, which has got its own history, which I won't go into. But all new car carriers now, if they want to travel over height or over length, they have to be PBS compliant. So they don't go over mass, but mentioned tail swing was a big problem for car carriers because of the large rear overhang. And a colleague of mine did a little analysis of the car carriers in South Africa this was in about 2012. And we had car carriers with rear overhangs of 7 meters. The regulation allows 30% of the wheelbase, but there's no absolute maximum. In Australia, there's an absolute maximum rear overhang of 3.7 meters. So whereas in Australia, the tail swing was limited to about 0.3 meters, we had car carriers with tail swings going up to 1.25 meters. That means when the driver does a 90-degree turn, the rear corner of the trailer swings out by 1.25 meters, which is a bit of a safety concern for road furniture, gates, etc. And with the PBS implementation of the PBS in the car carrier sector, those rear tail swings have reduced dramatically. And some companies have shown, in particular vehicle delivery services, I won't show you the graph, but when that's part of OneLogix, they had in 2016, I think they had 126 crashes. And the last few years, they've been sitting at around 7, 8, 10 crashes per year. So their crash rate has reduced by a factor of 10. Yeah, I'll skip this one. Coca-Cola are running a number of these vehicles, especially in Gauteng and then going up Limpopo, Free State. It's also a 30-meter rig. You see them on the N1 and the R21. In fact, if you're not aware of it, you'll pass it and you won't even realize that it's such a long vehicle. And this little clip shows the launch of their first PBS vehicle in Bloemfontein at their bottling plant. It's a Volvo 610. 30 meters, it's got triaxles on each of the trailers. It's what we call an A-double. And the rear axle of each tridem is a steer axle. That's to improve the low-speed swept path, as I mentioned earlier. And this little clip, you'll just see as the vehicle goes from the provincial road onto the N1, how well it turns, and that links to that video clip I showed you a bit earlier. You can see now it's about to go onto the N1. It's 30 meters long, and just because of the steer axles and the point, it performs incredibly well. The Citrus Growers Association, I've been working with them for about a year now, and they are very excited about introducing PBS vehicles for their fruit export. It's a very competitive market. The Europeans are, emissions per kilogram of fruit is a big thing. So you've got to look at your whole logistics chain, what the emissions are. So reducing fuel consumption on their road transport is very important. They're also keen on keeping fruit on rail, but that has its challenges. So they are actively looking at possibilities. In fact, I'm going up to Loskop Valley next week to meet with some of the farmers. This is an Australian PBS vehicle for fruit transport, a refrigerated combination. So it's got a payload of 56 tons compared with a standard truck, which would probably have a payload of about 35, 36 tons. So there's a lot of potential for fruit export. This just shows the growth of the PBS project up until 2023. All the different companies that have on board, as I mentioned, they're now about 90. Many of you are aware that the Western Cape didn't participate in the PBS project since the beginning for various reasons. And in the last 2 years, they started looking at it and developed their own strategy, and in fact launched the PBS project in the Western Cape as from the 1st of November last year. So they've actually going it quite aggressively. They've got their own little website, a provincial website. They talk about the RTMS and PBS. This is shows the savings. That's actually as at probably October last year. So at that point, about 600 million kilometers traveled, comparing baseline with PBS vehicles in all the different sectors. So the savings does vary depending on the type of vehicle and the commodity. But on average, we're saving about 1 million trips per year in the pilot project, 31%, about 270 million kilometers a year. Fuel saved on average is 84 million liters, 24%, same as for the greenhouse gas CO2 emissions. The crash rate reduction is 39%, and that's comparing with RTMS certified fleets. All the baseline vehicles are from RTMS certified fleets, and the average reduction in fuel consumption, in roadway cost, is about 12%. Some people have challenged the 39% reduction in road crashes. I can tell you now that in Australia, I'll show you some stats. Their reduction in crash rates at the moment is 55%. So our 39% is not unrealistic. This is the growth of the PBS project in Australia. Since they introduced it into their regulation, which was 2008, last year they exceeded 30,000 PBS approved combinations. You can see the last 2 years, over 5,000 approvals. So we're still quite a bit behind. My friend Les Brucer, who's the National Heavy Vehicle Regulator in Australia, I've known him for many years. That's him in the Father Christmas outfit. Every year he poses in front of one of his pet projects and at Christmas time and distributes it as part of his Christmas card. This is a PBS combination in Brisbane Port. He came up with this idea of transporting empty containers within the port. You can see there are 6 containers. I'm not sure how long this vehicle is. It's probably not much more than, probably between 30 and 40 meters. No, must be 40 meters. Obviously limited to a speed of maybe 30 or 40 kilometers an hour, but it is a PBS, quite an innovative PBS combination. Les Brucer is actually part of our review panel. And we had a review panel meeting on Tuesday this week, and he presented on a new performance standard in Australia on braking performance. So this is something that we will look at and possibly introduce, but it's to do with roll stability control. So the various providers of this technology, you get a technology called roll stability control, which applies brakes differently on the not just on different axles, but on different sides of the vehicle. So when it's not just about preventing jackknifing, which is another thing, that's EBS. Roll stability control monitors the roll of the trailers. So once the roll goes beyond a certain point, then the roll stability control kicks in, and it starts to brake the different wheels differently, which then sort of rectifies that. As the vehicle starts to roll, it brings it back to. So it's an additional stability control mechanism. Anyway, so with our analyses of all the different PBS projects, we always look at the baseline vehicle, and as I intimated earlier, 56 of the baseline vehicles that we've assessed fail at least one of the performance standards. 13%, no, I won't say that now. Yeah, 56% of the baseline vehicles fail, and the PBS vehicles, 13% pass level 1. So like the fuel quad I mentioned earlier, that's a level 1 PBS vehicle, 85% level 2, and then there's a very small percentage of level 3 and level 4, which are those road trains I spoke about. And if you look at what performance standards the baseline vehicles fail, they are all high-speed performance standards. So static rollover threshold, which I showed you a bit earlier, rearward amplification, and then yaw damping coefficient. That is, yaw damping is when a vehicle sways, sort of rotates on its axis, and it's the yaw damping is how quickly from a pulse steer at the steer axle, how quickly the vehicle stabilizes and becomes stable again. Because as you put in a pulse at the steer axle, the trailer starts to rotate on its vertical axis, the trailer and the truck, and you want to see that should damp. The yaw damping should be quick. And those are the performance standards that a lot of our standard prescriptive vehicles fail. This was an OECD project that I was involved in called Moving Freight with Better Trucks. And there's a whole lot of countries involved. They all provided what we call their workhorse trucks. So those are the trucks that are the most common in those countries. You can see Australia, ZA, South Africa, we provided 4 trucks, 4 combinations. And there's a whole lot of European countries, Canada, Mexico, United States. This graph is for static rollover threshold. And as I mentioned, the minimum requirement is 0.35 G. That's that red line there. And if you're below that, you fail. Our 4 trucks from South Africa passed. There's 2 truck tractor semi-trailers and 2 B-doubles or interlinks. But you can see a number of the European trucks failed the static rollover threshold test. These are workhorse trucks. So these are very common trucks in Europe. But because of their compliance, much higher levels of compliance, speeding, etc., they probably have a much lower crash rate than we do. But it just shows you that even in developed countries, if you apply the performance standards, you find that a lot of the trucks don't pass. This is our monitoring of the crash rates. And when we started, and this is accumulated crash rate. So when we started in 2010, well, this graph goes back to 2010, the crash rate of the baseline vehicles was about 4 per million kilometers, and the PBS vehicles about 2 per million kilometers. So there was a 50% difference. And then as the number of kilometers increased, you can see how it stabilized. So by 2021, you can see it's become very stable, the crash rates. And as I mentioned just now, the difference at the moment with after 600 million kilometers is about a 39% reduction in crash rate. And then you can do some estimates in terms of savings from reduction in crashes. This is based on a study that the CSIR did some years ago on cost of crashes. So I estimated 450,000 average cost of a crash for a PBS vehicle and 400,000 for a standard truck. I mean, that's like a whole range of crashes, obviously. And so you can do a rough estimate of savings about 260 million a year on crashes. That's a very much a thumb suck. So thanks, Amon. That's the second presentation on the pilot project.
Okay, thank you very much. But before we start the last presentation, there's 2 questions. Is there a requirement for the horsepower for a tractor of a PBS vehicle?
I'd love to know who asked that question.
It's Willem again.
Willem. Hi, Willem. Yeah, that's a very good question. In fact, it's actually I wish if I had some prizes here, I'd give you a prize. There have been concerns over the years of certain PBS vehicles traveling too slowly on hills. We had feedback, and some of the PBS vehicles were using 440s. And even though they pass all the startability and gradability standards, and acceleration capability, those are the 4 standards to ensure adequate acceleration and adequate speed, both on a level level gradient and also on a steep gradient. These vehicles are passing, and yet there was concerns. 440 just doesn't seem right. So we actually had a working group meeting in January with a whole lot of people looking at minimum speeds, and we engaged with Martin Damon from Truck Science to do some calculations from a 440 all the way up to a 630. We didn't do a 700, we did a 630 horsepower, and each of them has a minimum torque. And we looked at minimum speeds from a baseline 56-ton rig up to a 87-ton PBS vehicle, and we looked at minimum speeds on gradients from 0 up to 8%. To cut a long story short, we felt that it's more about route approval than setting a blanket minimum torque for PBS vehicles, because a lot depends on the route. So if you're running on the N3 and you've got Town Hill and you've got Marion Hill, you've got Key Ridge, you've got Van Rieenen, you shouldn't be running, the provinces should be limiting those vehicles and specifying a higher requirement. But we haven't resolved that because it was raised again at our meeting on Tuesday. And Les Bruiser said that the Australians are currently doing a study now to look at revising those performance standards, because they're having similar issues there. So it's a very relevant question, and I think we might be looking at increasing those requirements, those performance standard requirements for startability and gradability. But having said that, my experience traveling around the country is that it's the foreign vehicles that are by far the slowest on some of our hills, and I don't know what to do about that, because they really. So that 700 that I went on last week, the 700 with 100 odd tons, that slows down to 24 kilometers an hour on hills, steep hills, which is about the same as a standard 56-ton truck. On an 8%, 7% gradient, they will slow down to about 22, 24 kilometers an hour. But that's with a 700 horsepower. If you're running a 72-ton PBS vehicle with a 440, you're going to slow down to 16 or 18 kilometers an hour. And for us, that's not acceptable. Even though the foreign vehicles, sometimes I think they're traveling at 10 kilometers an hour.
Okay, thank you very much. And there's one more question.
Yeah, I see that.
Yeah, is there specific additional training or licensing required for drivers?
Not licensing, but training, yes. In the Smart Truck Rules document, there's a section for drivers and training. And so remember, with the RTMS, there's a requirement for annual training of drivers to cover a whole broad range of topics. And for PBS vehicles, there's some additional topics, like it's knowing braking of a much heavier vehicle, route compliance, the fact that permits are required. So it's basic stuff. There's a requirement in terms of the age of the driver, minimum years of experience. So there are a few requirements. The maximum age is 60, but it's open to application. So we have had applications from operators where their driver has got 20 years experience. He's been driving PBS vehicles for 5 years, and then they apply to extend that. And I think we're happy to go up to 65 at this stage. So there are some additional requirements, but they're covered in the Smart Truck Rules document.
Okay, thank you very much. No further questions. I think we can go to the next presentation.
Okay. So this is a relatively short presentation. Hopefully possible that the title might be wrong again, but it's not a train smash. So this is just to inform you about the application process. And I think you are very familiar with the PBS project. That's the rules document again. That sort of covers from A to Z how to get involved. This is a flow chart that's in Appendix F that shows the different steps, and I'll go through them from the RTMS requirement, 6 months accreditation, the concept design. You get your concept approval from the provinces. Each province, you need to get concept approval from each province. Then you do your safety assessments, your safety and infrastructure assessments. That goes to the review panel for approval. Then you theoretically only then should you order your trucks and trailers. Some operators order in advance because of the delays. And then the commissioning of the vehicles. And finally, your permit application. There's a more complex flow chart also in Appendix F, but I'm not going to go into that, but it's pretty much similar. I can skip that. So as I mentioned, the RTMS, I've shown this slide before, but we really believe that RTMS certification is an absolute minimum requirement for participation in the PBS project for high capacity vehicles. So for your concept design, you need to know what the truck looks like, so that you will get the GA drawings from the trailer manufacturer, and that will indicate the length, the axle masses, maximum combination mass, and the maximum payload. So this one, side tipper here, has got a maximum payload of 50.1 tons. It's a 9-axle, and these are the ones that are very common. You also, in your application, you have to describe the routes that you want to use. So here you can see there's an origin in Gauteng going through to Durban Harbour. That would be the one map. And then the origin, the destination, you'd have to provide a more detailed map, as you can see on the right-hand side, showing exactly the route that this vehicle is going to use to access the destination. And similarly, if you go through a town like Ermelo or Piet Retief or some of these towns that don't have a bypass, you would have to also indicate the route that the vehicle is going to take. And that's one of the advantages for towns like Kroonstad or Ermelo or many of these smaller towns, Carolina. The road authority can specify that the PBS vehicles need to follow a particular route through the town. So you don't have trucks just parking anywhere, traveling around. So the PBS vehicles would be limited to a particular route. And then so in your application, as I mentioned, you specify the routes, your GA drawing, the number of units that you want to apply for, and then some specifications on the truck tractor, the trailers, the GVMs, the GCM, the tear masses, etc., and then the overall dimensions, the commodities that you want to transport, because the commodities are taken into account when the PBS safety assessment is done, because different commodities have different densities and then different center of gravity heights. Because you combine the center of gravity height of the payload with the truck, the actual truck, to get an overall center of gravity height. So this is an example of a concept approval application letter, concept approval letter from the province. And normally these letters are valid for 1 year. So that means that from the time you get this approval, you need to get a truck on the road within a year. Otherwise, that concept approval will expire. If you've applied for 20 trucks, it doesn't mean you have to have all 20 on the road. You just have to have at least one on the road. In other words, follow the process through within the 12 months. And then here you have the assessments. So there's a safety assessment. That one was done by Rob Berman, who was at the CSIR. At the moment, we've got 3 accredited safety assessors. So they can do the safety assessment. The bridge and roadway assessment is done by the CSIR. And those then get, obviously the vehicle, if the vehicle doesn't pass either of them, then there's a bit of backwards and forwards between the operator and the assessor to make some changes to get the vehicle to pass. So that quite often happens. It's either safety performance standards, or sometimes the infrastructure performance standards don't pass. The roadway assessment is over the 0.2 limit. And then one has to play around a bit to get the vehicle to pass. And then the safety assessment gets a stamp on it with a PBS number. And that's required eventually when the vehicles are commissioned. And of course, when you apply for your permits. So here's an example I showed you earlier. If the vehicle is more than 22 meters, then the length of the vehicle is also included on the abnormal load board. So you saw some of the others where it's 30 meters long. There's an indication on the length of the vehicle. Then you get to the commissioning. So each and every PBS vehicle needs to be commissioned by an accredited commissioner. And I think now we've just had approved a new commissioner on Tuesday. So I think we've got 1, 2, 3, 4, 5. There are five active PBS commissioners. And they will go out and do some checks on the final product. They'll make sure that the boards are up, the amber flashing lights, check a number of dimensions. If it says 4 stabilizer bars, make sure they're 4 stabilizer bars. Measure the track width. There's a whole number of checks that are done. And we've developed checklists that for the different types of combinations of the things that need to be checked. And the commissioner will then issue a commissioning letter for each vehicle combination that specifies the actual dimensions. And there's a bit of a tolerance, obviously. So for all the dimensions, there's a bit of a tolerance. Fifth wheel position is very important. Length of the drawbar, hitch position. So this is a checklist for A double. And then finally, you apply for your permit. A lot of operators use transport consultants to do the permit applications. And once you've got your permit, then you're good to go. I might just add that there's quite an issue with the permit fees. I won't go into the history, but really based on a decision at the Abnormal Loads Technical Committee about 12 or 15 years ago, it should have been then 5,000 per province, which has been escalated. It was only KwaZulu-Natal and Eastern Cape introduced that. All the others carried on with the 32,500, which was the permit fee, which was supposed to be split between provinces. So at the moment, you've got astronomical permit fees if you're running from Joburg to Durban through 4 provinces. And this is another issue that we still want to take up with National DOT to rectify those fees. That's my short presentation. I think we're still okay for time. Thanks, Amon. Maybe there's a couple more questions.
Thanks, Paul. We have one more request. Rajen is requesting us to expand the discussion on the movement of containers using PBS units. So is that happening in South Africa, and how is it taking place, if it is happening?
Yes, there are a number of PBS combinations that are using containers. The challenge that we've had with, especially from some of the review panel members representing provinces, is how to regulate the payload. So you have to specify the payload, and with containers, usually there's mixed goods. There are some where it's a single product, and we still haven't quite got our head around how that, how do you monitor that the operator is complying with those products? I remember I did a project with one company for pallets of tin goods. So they had about 6 different pallet sizes for the different types of tinned food, slightly different dimensions, slightly different masses, sort of from about 900 kilograms to 1.1 tons. And so you can do your PBS assessment, assuming those different size pallets. You obviously do a worst case assessment. And then, but sometimes you get much more variation than that. And, it's not likely that you're going to put the toilet paper underneath with the pallets of tin fruit on top. It's not going to work. But still, how do you regulate essentially the center of gravity height in the containers? But as I say, we're looking at it. We're working on proposals for containers, and there certainly are some on the road. And this, as I said, the citrus growers are looking at export, and they would have different pallet sizes for the different types of fruit, which have different masses. And I think we'll go there. We'll get there. It's all about the compliance, really, ensuring compliance. Yes, I see that the Reinhardt MBH, so they're running a mining product in those containers on the Durban-Joburg corridor. So that's a fixed product, so that was fairly easily approved, but then they want to transport some other products as well. And we've been having a bit of backwards and forwards how to, monitor that. But we'll get there.
Okay, thank you. And Rajen is also asking whether that's the same with ISO tanks. I'm not sure if you've touched on that already.
Yeah, the same would apply to ISO tanks. I think it's. I'm not aware of any. I don't think there are any, but the same would apply. I think maybe no. In fact, in Namibia, I think Van der Walt Transport are also transporting ISO tanks.
Thank you so much. I don't see any other questions, and we still have about 26 minutes. But if there are no further questions, then we will close the webinar. I would like to thank everyone for joining today's webinar, and we hope the insights shared have enhanced our understanding of how PBS can improve road safety, support innovation, and add real value to our operations. A special thank you to you, Dr. Paul, for an excellent presentation and for sharing your expertise. Thank you so much for that. And for our participants, please look out for the follow-up materials. Samantha has shared a link where you are going to view the recording, and please contact us if you have any questions or would like further guidance. We will be in touch with Dr. Paul if we have such requests, and he'll be able to assist you. So we appreciate your participation and wish you a productive rest of your day. Thank you so much.